An isolation panel for surgical suite is a specialized electrical panel designed to provide isolated power to critical equipment. The transformer is a core component. It converts a 277 volts input into a 59.5 volts output on what's called a phase. The term phase in this instance doesn't refer to a three-phase electrical system. Instead, it signifies a single isolated circuit created by the transformer. Circuits within the isolation panel are connected to tandem circuit breakers. These breakers are connected in series, so both trip together if either one opens. This provides redundancy and added protection. The tandem circuit breakers are interconnected to deliver 120 volts between them. This occurs because the 59.5 volts output from the transformer is sent to tapped, generating two 120 volts legs. The primary function of the isolation panel is to supply isolated power to surgical equipment. This is accomplished by firstly, using a transformer to create an isolated circuit, secondly, isolating the equipment from the regular electrical system, and thirdly, providing redundancy and added protection through tandem circuit breakers. By offering isolated power, the isolation panel minimizes electrical hazards to patients and staff. It ensures the safe operation of critical medical equipment. The isolation panel employs a transformer to step down the voltage from 277 volts to 59.5 volts. This lower voltage is considered safer for use in a medical environment. The transformer also provides electrical isolation. This prevents any leakage current from the main power supply from reaching the surgical equipment or the patient. The center tap on the 59.5 volts winding creates two 59.5 volts legs. When these legs are connected in series through the tandem circuit breakers, they provide a total of 120 volts. The tandem circuit breakers offer redundant protection. If one breaker trips, the other breaker will also trip, interrupting the circuit and preventing any electrical hazards. The isolation panel isolates the surgical equipment from the regular electrical system. This means that any electrical faults in the building's electrical system will not affect the surgical equipment. The goal is always to ensure a safe and reliable power supply for critical medical equipment. Firstly, the 277 volts power supply is fed into the primary winding of the isolation transformer. Secondly, the transformer steps down the voltage to 59.5 volts on the secondary winding. Thirdly, the secondary winding is center tapped, creating two 59.5 volts legs. Fourthly, the two 59.5 volts legs are connected in series through the tandem circuit breakers. Fifthly, the tandem circuit breakers provide 120 volts to the surgical equipment. Sixthly, the isolation transformer provides electrical isolation between the primary and secondary windings. Seventhly, the tandem circuit breakers provide redundant protection against overcurrents. Eighthly, the isolation panel is typically equipped with a ground fault monitoring system. This system detects any leakage current from the surgical equipment to ground. Ninthly, if a ground fault is detected, the system will automatically trip the circuit breakers and disconnect the power supply. Tenthly, the isolation panel is designed to meet the requirements of the National Electrical Code, specifically Article 517, which covers healthcare facilities. The isolation transformer is a key component in the isolation panel. It provides electrical isolation, steps down the voltage, and creates the center tap for the 120 volts output. The selection of the appropriate transformer is critical to the performance and safety of the isolation panel. Firstly, the transformer must be sized to handle the total load of the surgical equipment. Secondly, the transformer must have a high isolation voltage rating. Thirdly, the transformer must be designed to minimize leakage current. Fourthly, the transformer must be listed by a recognized testing laboratory, such as Underwriters Laboratories, or OL. The tandem circuit breakers are another important component of the isolation panel. They provide redundant protection against overcurrents and short circuits. The selection of the appropriate circuit breakers is also critical to the performance and safety of the isolation panel. Firstly, the circuit breakers must be sized to protect the surgical equipment. Secondly, the circuit breakers must have an appropriate interrupting rating. Thirdly, the circuit breakers must be listed by a recognized testing laboratory. The ground fault monitoring system is an optional component of the isolation panel. It provides additional protection against electrical hazards. The ground fault monitoring system detects any leakage current from the surgical equipment to ground. If a ground fault is detected, the system will automatically trip the circuit breakers and disconnect the power supply. The installation of the isolation panel must be performed by qualified electricians. The electricians must be familiar with the National Electrical Code and the specific requirements for healthcare facilities. Firstly, the isolation panel must be installed in a dry, clean location. Secondly, the isolation panel must be properly grounded. Thirdly, the wiring connections must be made securely. Fourthly, the circuit breakers must be properly labeled. Fifthly, the ground fault monitoring system must be tested to verify that it is functioning properly. Regular maintenance of the isolation panel is essential to ensure its continued performance and safety. The maintenance should be performed by qualified personnel. Firstly, the isolation panel should be inspected regularly for any signs of damage or deterioration. Secondly, the circuit breaker should be tested to verify that they are functioning properly. Thirdly, the ground fault monitoring system should be tested to verify that it is functioning properly. Fourthly, the wiring connection should be checked for tightness. Fifthly, the isolation transformer should be inspected for any signs of overheating. In summary, the isolation panel is a specialized electrical panel that provides isolated power to critical equipment in surgical suites. It uses a transformer to create an isolated circuit, isolates the equipment from the regular electrical system, and provides redundancy and added protection with tandem circuit breakers. By providing isolated power, the isolation panel helps protect patients and staff from electrical hazards and ensures the safe operation of critical medical equipment. The 59.5 volts output derived from the 277 volts input via the transformer is a key element. The center tap creates the two legs which, when combined, deliver the necessary 120 volts for operation. The tandem breakers act as a double check, ensuring that in the event of an overcurrent or fault, the circuit is rapidly and reliably interrupted. This arrangement minimizes the potential for electrical shock and ensures a safe environment during surgical procedures. Understanding the principles behind the isolation panel, including the transformer's role in voltage transformation and isolation, the function of the center tap, and the purpose of the tandem breakers, is crucial for anyone working with or maintaining these systems. The National Electrical Code provides specific guidelines for the installation and maintenance of isolation panels in healthcare facilities. Adherence to these guidelines is essential for ensuring patient and staff safety. The selection of components, such as the transformer and circuit breakers, should be based on the specific requirements of the surgical suite and the equipment being powered. Regular testing and maintenance are necessary to verify that the isolation panel is functioning correctly and providing the intended level of protection. Ground fault monitoring systems can provide an additional layer of safety by detecting leakage currents and automatically disconnecting the power supply. These systems are particularly important in surgical suites where patients may be more vulnerable to electrical shock. Isolation panels are not limited to surgical suites. They can also be used in other healthcare settings, such as intensive care units and cardiac catheterization labs, where electrical safety is paramount. The design and configuration of the isolation panel may vary depending on the specific application, but the underlying principles of voltage transformation, isolation, and redundant protection remain the same. The proper functioning of an isolation panel is vital for patient safety in surgical environments. The use of a transformer to create an isolated power source is paramount in minimizing the risk of electrical shock. The tandem circuit breakers provide a redundant safety mechanism, ensuring rapid circuit interruption in case of faults. The 120 volts output, created from the center tap 59.5 volts transformer output, powers the necessary equipment. Proper installation and regular maintenance are crucial to guarantee the continued effectiveness of these systems. Ignoring this is never an option.